Hello everyone, this is Solo Chem Lab. We have a problem on the board to be solved. Which of the following gases will diffuse most rapidly? Which of the following gases will diffuse most rapidly? Some options are given and we're expected to pick the correct option. Before we continue, are you a chemistry student or a chemistry teacher? Do you own a school and you want your science teacher to be exposed to virtual science laboratory such that you may not even need a real life science laboratory so much? You may not need to buy chemicals all the time. So Lochem Lab offers such services. Are you in the house preparing for JAM or WAEC or NECO exam? And there are some problems, especially in chemistry, that you find difficult? Get in touch with the Lochem Lab using this contact. And don't forget, on Tuesdays and on Thursdays, Solochem Lab comes live, where you can interact with the teacher one-on-one, 5 p.m., Tuesdays and Thursdays. Over to the problem on the board. Which of the following gases will diffuse most rapidly? We need to define diffusion first of all. Let's define diffusion. Have you been in a place where someone sprays perfume without you knowing when the perfume was sprayed? After some time, do you get to know that somebody has sprayed perfume, maybe when you were in class? How do you get to know? You get to know because the particles of the perfume move from where the person sprayed it, though while hiding. The particles spread and get to your nose, your nostrils, and you are able to perceive the smell of the perfume. Do you understand? What phenomenon is illustrated by the movement of the particles of the perfume? Diffusion. So what is diffusion? Diffusion is the movement of particles, especially gas particles, from a region of high concentration, that's where they are plenty, to a region of low concentration, that's where they are few. Do you understand? Let's take it again. Diffusion is the movement of particles from a region of high concentration to a region of low concentration. Is that clear? All these substances on the board are gases at room temperature. The first one is chlorine gas. It's a diatomic gas. It's made up of 2 atoms of chlorine. The next one is a sulfur 4 oxide, SO2, sulfur 4 oxide. The next one is CH4, that's methane. And then the last one is C2H6, that's ethane. It is an alkane. And we're asked to find out which of them diffuses most rapidly. In your SS1, you were introduced to what we call Graham's law of diffusion. Do you still remember? Graham's law of diffusion. What does it say? Graham's law of diffusion states that at equal temperatures and pressure, if you are comparing two gases, the lighter one will diffuse faster than the heavier one. Do you understand? Graham's law of diffusion says that the rate of diffusion of a gas is inversely proportional to the square root of the vapor density. The rate of diffusion of a gas, written as R, is inversely proportional. Inverse means 1 over. Inversely proportional to the vapor density. The Greek letter rho that we are seeing here refers to what we call vapor density, the density of the vapor. What does that mean? It means that the heavier the gas, this is kind of an inverse proportionality. So the heavier the gas, the smaller the rate of diffusion. Do you understand? The lighter the gas, the faster the rate of diffusion, provided the temperature and pressure are kept constant. Do you understand? It's like when you have two students, one is fat, very, very fat, weighing, let's say 200 kilograms, an SS1 student, very fat, weighs, let's say 200 kg. And you have another slim SS1 student weighing 40 kilograms. And you put a 100-meter race for them during inter-house sports. Tell us, who will get to the finish line first? The slim student. Why? Because his mass is small. His density is small. The fat person has a high density, high mass. Do you understand? That's the illustration of Graham's law of diffusion. So what we're going to do now is let's find the molar mass of each of the gases here. The lightest gas, the gas that has the smallest relative molecular mass, will have the highest rate of diffusion. Then the one that has the highest relative molecular mass will have the lowest rate of diffusion. Do you understand? Now let's solve. Cl2, that's 2 atoms of chlorine making up this gas, diatomic gas. We are given information. Why gave us information here? Do you know what Why gave us? Why gave us the relative atomic mass of each element. The relative atomic mass of each element. Hydrogen, 1, that's the relative atomic mass. Carbon, 12. Oxygen, 16. Sulfur, 32. Chlorine, 35.5. So when we come here, chlorine, Cl2, a diatomic gas, we simply multiply 35.5 by 2. Do you have your calculator there? Do you want to make use of place value that you were taught in primary 4? 35.5 times 2 gives us 71. Then option B, SO2. SO2. That is 1 atom of sulfur, whose atomic mass is 32, plus 16 times 2. Do you know why we're multiplying by 2? Because there are 2 atoms of oxygen. Atomic mass of oxygen is 16. 16 times 2. What is it going to give us? 32. 32 plus 32. 64. Is that clear? Then we'll come to methane. Methane, CH4. Atomic mass of carbon, 12. Plus atomic mass of hydrogen, 1. Times what? Times 4. Why are we multiplying by 4? Because there are 4 atoms of hydrogen in this compound. So 1 times 4, 4 plus 12, 16. Is that clear? Then we'll come to ethane, the last compound here, the last gas. 12 times 2, that is carbon, is 12. There are 2 atoms of carbon. So 12 times 2, what will it give us? 24. Plus 1 times 6. 1 is for hydrogen, times 6. 24 plus 6. What is it going to give us? 30. Which of these relative molar masses, which of these relative molecular masses is the smallest? Is this one here, 16. That's for methane. So, if you want these gases to diffuse, you give them the same condition of temperature and pressure. Which one will diffuse? Which one will move from one point to another point at a fastest rate? Is this one. So this is the one that will diffuse most rapidly because it is the lightest gas of all these ones given to us. Do you understand? That's the correct option. Which of the gases would diffuse least rapidly? You check. The one that has the highest relative molecular mass. That's chlorine. This one will diffuse least rapidly because it's the heaviest gas here. But the one that will diffuse most rapidly is the lightest gas, and that is methane. Is that clear? Do you still have any question you may want to ask about chemistry? Don't forget, Tuesdays, Thursdays, 5 p.m. you can get in touch with Solo Chem Lab one-on-one. Do you remember the contact? Contact is here. For now, have a good day.